So question 6. Here we're given this function f of x, and we are told that this shaded region R is rotated about the x-axis by 2 pi radians, so completely around the x-axis, and we need to show that the volume is given by this formula. So all we need to know here is the volume of revolution, the formula for it, which is in the data booklet. Since here we are rotating about the x-axis, we're going to need to use the formula v is equal to from a to b, pi times y squared dx. So the function we're given is already in the form of y, so we don't need to do anything. We just need to plug it in and integrate it. So let's do that. So the volume will be equal to the integral from 0 to root pi over 2, and the function will be, well, it will be pi times the function squared, so square root of x sine x squared, and all of this squared dx. So very nicely the square root will disappear. Like this. And well, what we need to notice here is that we can do a u substitution. So if we say that u is equal to x squared, then du dx will be 2x, and so dx is equal to du over 2x. Now if we change from the x world to the u world, we also need to change the limits of integration. So we need to see that when x is equal to 0, what is u, and when x is equal to root pi over 2, what is u. So when we rewrite this integral, well, when x is 0, u is also going to be 0 according to this formula. And when x is root pi over 2, then u will be simply pi over 4. Now when we plug this in, we can say that x times the sine of u, we also replace dx by du over 2x. So we see that the x's cancel out. So we have times pi, obviously. So we'll have 0 to pi over 4, like this. And then we can bring the constants out to the front. So this will just be pi over 2 times this. And then we simply have a sine of u du. So this will be pi over 2 times, well, the integral of sine is minus cosine. Like this. And we need to plug in pi over 4 and 0. So this will be equal to pi over 2 times minus cosine pi over 4. So that's minus root 2 over 2. And then, well, cosine of 0 is going to be, so it will be minus cosine 0, so that's 1. And then when we plug in, we'll have to subtract minus cosine, no, sorry, so minus, so here we still need to plug in, no, it's just minus 1, so it will be minus root 2 over 2 minus 1 when we plug in 0, the lower limit. So it'll be minus minus 1, like this. And well, what we notice here is that this is what we had to show. So we have shown what the question is asked.